All right, there's a lot going on here in number one. Let me just pull some things out here right at the beginning. So you got this student council president, this first candidate, it's got to get over 50%. All right, got to get over 50% of the votes to be elected. So what happened was they went out and they took a poll, and here's what they found. Of 50 students they sampled, 26 said they voted for candidate A. All right, so of the 50 they sampled, 26 voted for candidate A. That right there, what they went out and sampled, we're going to give a name to it. That's called my observed proportion. If I knew how to spell. All right. Whatever went out and was sampled is going to be our observed proportion. And we need it as a decimal form. And I'll show you why we need it as a decimal at the end. So they did 50, and how many voted for them? 26. So 26 out of 50. You guys can do that right on your calculator for me. 26 out of 50. 0.52. All right, so here's what we're going to do today is, how reliable is that? Does that match reality? Like, oh, I went out and sampled 50 kids, 26 said they're voted for candidate A, it's going to be candidate A automatically. All right, how reliable is that one little sample that we just did? Or did I just pick the right kids? Right? Did I just pick the right kids who are going to vote for candidate A? So that's what we're going to do today is, how reliable is this observed proportion? Does it really truly represent the school population, or is it just kind of like an outlier? Right? That's what we're going to test today. All good. How reliable is that observed proportion? Is it really like the school population overall, or is it not? And the way we're going to do that is, and this is why I did this with you on Friday, and if you weren't here on Friday, got to catch up somehow. We're going to see if the observed proportion fits in our confidence interval. That's what we're going to do. Does it fit into our confidence interval? So we'll have to review that. So what we're doing here, because I think as you guys, one thing at least you could have gotten from this unit is the more and more and more and more samples we do, the closer we get to the actual answer, don't we? The true mean, the more and more samples. So here's what we did. We did a computer simulation. All right. We did 50 samples 100 times. So here's what we did. Went out, get 50 people. Come back, tell me the results. All right, go back. Give me another 50 people. Tell me the results. We did that 100 times. So let me do that quick math for you there. That's 50,000 students we've sampled. That gives us a pretty good deal. All right, so we went out and sampled 50,000 students. So we went out and did 50. All right, let's say, don't write this down. Let's say the 50 came back and it was, let's say it's 30 out of 50. What's that as a proportion? 0.6, I think. So we graphed 0.6 on here. Then I went out and sampled another 50. And let's just say it came back as 20 out of 50. That's 0.4. So I graphed 0.4 on here. So there's 100 of these dots on here. All right, that represent the 50,000. And I calculated the mean and the standard deviation. You guys help me now find the confidence interval. How do I find the confidence interval from Friday? How do I find the confidence interval? Again, it's a formula. We're going to need it for Friday or Thursday, whenever you're taking this bad boy. Confidence interval. Mean. Plus or minus. Mo. And how do I find the mo? The margin of error.
The standard deviation.
Plus or minus 2 times my standard deviation. That's the margin of error, remember. That's the margin of error. So now we'll really find out if that 0.452 is reliable, or is it just like an outlier. So go ahead here. I gave you the values right over here. So your mean is 0.497 plus or minus 2 times 0.069. All right, do your work. Do your magic now. Make sure you add and subtract it from the mean. .359 to 0.635. We get that as our confidence interval. Are we good there? Okay, again, from Friday, you guys that were here, what percentage confidence is this? 95%. So here's what we're saying. We are 95% confident about 36% to about 63.5% of kids voted for candidate A. We're 95% sure it's somewhere between there. So you look back at our observed proportion. Where does it fall? Inside or outside our confidence interval? Inside. So guess what? That's a pretty good representation of the school right there. That's not like an outlier there. Why? Because it falls in our 95% confidence interval. And we are 95% confident about 36% to about 63.5% voted for candidate A. All right? That's why we do so many of them. All right, we're pretty confident. Max, go ahead.
Will our confidence level always be 90?
Always. I will never ask for another one, and the regents will not ask for another confidence level. So that's confidence interval. That's why you can use this one going forward, that formula. Yep. Okay, so let's fill in the blanks here. So you guys get an understanding of grammar-wise what I'm looking for as an answer as well here. So the confidence interval was 0.359 to 0.635. So the observed proportion of the sample, and I should have did a blank here. So the observed proportion from the sample survey of, what did we find our observed proportion was again? I should have put a blank here for you guys to fill in. What was our observed proportion here? 0.52. Our observed proportion 5.2 is within or not within? Within the confidence interval. Are you seeing why I know this 0.52 is likely versus unlikely? Okay, because we are 95% confident it's somewhere in between here, and that's where our observed proportion fell. All right, so we know this is just not a outlier. Questions here. Find the observed proportion. Find your confidence interval. All right, next up. All right, now I'm going to do a spinner. Okay, numbers 1 through 5. Jack had some free time on his hands, obviously. So he spun that sucker 100 times, and it landed on 5 31 times. It landed on the 5 31 times. And he's like, is that likely or not based on this spinner? So we're going to find out if that's likely or not, that it comes up 31 times out of 105. All right, so my observed proportion. How do I calculate that here? What did he do? He did 31 out of 100, right? So his observed proportion, 0.31. And then he did a simulation, right? Because the more and more you do, the more confident we get in the actual results. 100 spins 300 times. So how many times did he spin that sucker? What do I have here? 30,000 times. All right, he spun that sucker 30,000 spins. And I don't need you to know that. I just want you to realize how much we're doing here and how reliable it becomes the more we do. So we graphed our results here in the dot plot. All right, is it likely that it would come out to be 31 out of 100 times? Let's figure it out. Confidence interval. You guys have been given the mean and the standard deviation, so go ahead and use the formula. And these, again, this is the number of times it came up, a 5. 5. So what do we got here? 0.117 to 0.281. Are we all calculating that correctly? So really we're saying here, hey, the number of 5s you should have gotten should have been anywhere from almost 12% to 28%. And look what we got, about 31%. So guess what? It's not really likely. All right, ours is not likely at all. There's everyone. So maybe it was because I had a crappy spinner or an unfair spinner. I don't know. Maybe it was weighted toward the 5s, but it is not likely. That's baloney. We can confidently say that's baloney that you would get it 31 times. All right, so you're lucky. All right, so these are the type of conclusions we can get out by finding the confidence interval. All right, so the confidence interval based on the simulation of 0.117 to 0.281. So the observed proportion of 5s was 0.31 is not within the confidence interval. And look, could we spin it more times? Sure, but 0.31 is never going to fall into it because what's going to happen when we spin it more times? This confidence interval is going to get smaller and smaller. All right, 0.31 is never going to fall in there. So you just got lucky. Questions? All right, one more here with you, and then I want to see you do a couple on your own. All right, look at that, senior class trip. If we're only going to do the senior class trip if 75% of the senior class wants to go on it. All right, only 75% want to go on it, we'll go on it. So to test this, we went out and sampled 100 seniors and 65 said they wanted to go on it. All right, so my observed proportion. How are you guys calculating your observed proportion here? 65 out of 100, which is 0.65. Now, hey, we just can't say, oh, that's it, we're done. I just surveyed 100 people. 65% said, nah, we're good. Or I want to go on it, but we need 75%, so I guess we should cancel it. No. You got to see if that 65% is actually representative of it overall. So we went out. What do we do here for this one? Surveyed 100 people 200 times. Again, you guys can figure that out. 200, add 2 more zeros on, 20,000 people we surveyed. And see if that 65 is actually likely. Find your confidence interval. Just can't rely on those 100 you sampled. You might have just sampled 100 that weren't feeling it, or 65 that weren't feeling it there. What about everybody else? What do you have for your confidence interval here?
0.664.
0.664 to 0.836. So is that 100 you picked representative of the senior class there? No, right? Because we're predicting about 66% to about 84% want to go on that senior trip. And all right, that's why you just don't take your first one. All right, you just don't go out and sample 100 and say this is what everybody else thinks, because they don't, obviously. So if you haven't filled this in, go ahead. 0.664, 0.836. Proportion 0.65 is not within the confidence interval. All right, think you can tackle one on your own here and see if Connor's coin here is good or not. See if this coin's good or not. 45 tails out of 100. Is that likely or not? Or does he have a weighted coin? Which they always talk about, but I've never seen one in my entire life. Yep.
If the observed proportion falls on the minimum or the maximum, is it within?
Yeah, right? Because it's this to this, including those. Yep, good question, Richie. $30,000 flips of a coin. 30,000 flips. And hey, just a heads up here at 4 and 5, I'm asking for the confidence interval to the nearest hundredth. All right, I need you guys to start rounding correctly. All right, 4 and 5, I'm asking for the confidence interval to the nearest hundredth and the directions. All right, confidence interval to the nearest hundredth. Here's what it's looking like for number 4. All right, again, nearest hundredth it's asking. So your observed proportion should have been 0.45. But hey, you flip a coin, you should get tails 40 to 60% of the time. All right, out of 100. 40 to 60% of the time you should get a tail out of 100 flips. So that was within, so that Connor's flips were pretty good. Nothing unusual about his flips. All right. And then if you haven't done so, go ahead and go to 5.
Mr. Galena, for number 5.
Yep.
For the observed proportion, would it be 25 over 100?
Correct. Yep. 25 out of 100. Yep. They said they wanted the team before.
Do we have a delta mark?
No. This is it right here. They're not. If you go on, that's tomorrow's notes. There's only so many of these type I can give you, but this leads into tomorrow's stuff too. So. Again, for this one, number 5, you go out and you survey 125, came back and said they want the team. You just can't say, forget it, no team, because we had to have the 30% say yes. Right? You don't know if that 25% represents the population or not. And the way you figure out, see if it falls within the confidence interval, and it did represent the population because it was 21 to 39%. All right? So tomorrow, last day of congratulations, Algebra 2 tomorrow. We're still going to be figuring out if numbers fall into a confidence interval, but just doing something a little different.
I think
And that's all this is. See if a number falls within or outside the confidence interval.
No.